I think one of the coolest things in nutrition is that if you simply alter the form of the exact same food, it can have completely different effects inside of your body. And now, a few examples of this are something like a cooked potato versus mashed potatoes. You'll likely get a better physiological response from the cooked potato than the mashed potatoes. Another example is taking an orange or taking orange juice. You'll have a much more favorable response from the orange than you will from the juice, even if it's the exact same amount of oranges, just in a diluted form. And now the reason for this is it all comes down to the physical structure of these molecules. So in their whole forms, potatoes and oranges have a lot of complex carbohydrate molecules. And this is what gives them their structure. And when we take a potato and we mash it, we break down these structures into less complex forms. These forms are smaller and easier to pull apart. Similarly, with an orange, when we juice the orange, and the same thing occurs when we take any sort of fruit or vegetable and grind it up into a juice. So why the heck are smaller molecules less favorable than these larger, more complex molecules? Well, it all comes down to the speed of digestion. As you likely know, our intestines can only absorb small, broken down molecules, and this is why we digest our food. The process of digestion is mechanically and chemically breaking down the complex structures that we eat into smaller structures that we can actually absorb and allow for entry into the bloodstream. And the more complex these structures are, the longer this process takes and the further down our intestinal tract it will travel. And there are two reasons why this is favorable. When we eat a food that's in a more pre-digested form, like mashed potatoes or a juice, we break it down fairly quickly and absorb it extremely rapidly. And this can cause a very large increase in our blood glucose levels. And I'll explain why that's important in a moment. But for these complex structures, it takes longer and smaller amounts of these small glucose molecules are absorbed, meaning our blood glucose levels won't actually spike extremely high. Rather, they'll stay mildly elevated for a prolonged period of time. But there's one other kind of unknown reason that more quickly digesting food actually increases our blood glucose levels quite drastically. And this is actually the location inside of the intestine that they are absorbed. So in the upper part of the intestine, where rapidly digesting foods will be absorbed, there's a specific cell type called the K cell. And these cells actually interact with these molecules inside of our intestine. And it's used kind of as a signaling mechanism to tell the brain and the rest of the body that there's food. And these K cells produce a molecule referred to as an incretin hormone. And this hormone is called GIP. And when this hormone is produced, it will actually increase our production of both insulin and glucagon. And now this is slightly paradoxical. Insulin will work to actually lower our blood glucose levels. And it does this by binding to the insulin receptor of specific channels, of nutrient channels that are inside the cell, specifically for amino acids, fatty acids, and glucose, to actually go from inside the cell to the membrane of the cell, which subsequently will allow glucose, fatty acids, and amino acids into the cell. And in this way, it will decrease the nutrient availability, specifically glucose, inside of our bloodstream. However, glucagon does the exact opposite. Glucagon will actually go to the cells and liberate any sort of stored fuel, meaning it will actually break down the stored glycogen, triglycerides, and even proteins into fatty acids, glycerol, glucose, and amino acids, and release them into the bloodstream. So consequently, this glucagon effect will actually increase our blood glucose levels even more. But remember, this occurs when rapidly digesting food is absorbed quickly inside of the upper part of our intestines. But again, these more complex foods like whole potatoes or whole fruits and vegetables will travel farther down our intestine and interact with a different subset of cells that's located in the deeper region of our intestines. And it gets a little confusing, but these cells are called the L cells. and they produce a different incretin hormone called GLP-1. And you may have heard of this hormone because it's being used for weight loss and diabetes management. And one of the reasons is because it helps control blood glucose. And this is because GLP-1 will typically only produce insulin and not glucagon, which means we won't have the additional blood glucose increase from the glucagon effects that are caused by GIP. So in these two examples, the more complex the structure of the food, even if it's the exact same macronutrients, can actually have two drastically different effects on our blood glucose levels. So why is this so important? Well, there are a few reasons for this, but one of them is actually for a sustained energy and appetite reduction throughout the rest of the day. When we have these very large increases in blood glucose, we have a very large insulin production. And the pancreas that produces insulin can't always produce the perfect amount of insulin to return our blood glucose back to normal levels. And most of the time, the pancreas will actually overproduce insulin, which will cause the entry of too much glucose into the cell to maintain normal glucose levels, and will end up having low blood glucose. And when we have low blood glucose levels, as a response to over-insulin production, we'll begin to feel tired and hungry kind of at the exact same time. And neither of these sensations are things that we would want. And because all of these molecules are digested so rapidly, the amount of glucose available in our bloodstream is very short-lived, meaning that quite soon we'll end up in a state of low glucose. But the longer something takes to digest, the more prolonged we'll have glucose in our bloodstream, and we won't have this sudden increase and sudden crash. And yes, we'll still produce insulin, but it won't be nearly as much. So the risk of going hypoglycemic or low blood glucose after this insulin production is not as severe or likely. And because we're absorbing this glucose at smaller rates for longer periods of time, we'll maintain a fairly stable glucose level for a longer period of time. And this is why ingesting things like fiber, protein, and fat sources, along with any sort of carbohydrate, will lower the blood glucose response to a meal. And this is because they make it a little bit more difficult to immediately digest the carbohydrates because they kind of compete for any sort of glucose molecules for absorption. Meaning we won't absorb as much glucose at each portion of the intestine, and these glucose molecules will be there for a longer time and travel further down the intestine. And I think the thing that I forgot to mention is that when we have smaller increases in glucose, we'll produce a little bit less insulin. And many diabetics can actually tell you why this can be so important. When we produce too much insulin, that insulin receptor that I talked about begins to become insensitive to the insulin molecule. And this is why eating a lot of carbohydrates extremely frequently will maintain a very high production of insulin and can lead to the insulin sensitivity characterized by diabetes. And there's a few reasons for this. One could be that the cells simply retract the insulin receptor from the membrane. The other is that myriad of processes that occurs to actually put the glucose channels into the membrane begins to become dysregulated. So even when insulin is binding to the receptor, the functions inside of the cell aren't actually occurring for insulin to do its job. And if we think about it, eating these very sugary sources of carbohydrates kind of is a self-perpetuating cycle. Because we get such a rapid decrease in glucose and oftentimes face the reactive hypoglycemia or low blood sugar caused by these very rapid spikes, we feel the urge to eat immediately thereafter. And we go through the same process of drastically increasing our glucose and insulin production, and then quite soon after having low glucose, so we do this cycle once again. But the more prolonged release of glucose allows for us to maintain satiety for a longer period of time, meaning not only will we produce less insulin, but we'll also feel the need to eat less often. And once again, I want to reiterate, this is simply just eating the exact same macronutrient in a different structure. Some great examples of this are instead of doing fruit juices, eating fruit. And instead of eating mashed potatoes or hash browns, simply opting to eat boiled or baked potatoes. And bonus points if you allow these potatoes to cool, because it actually increases the complexity of the glucose structures contained in the potatoes, and this is referred to as the accumulation of resistant starch. But there are also other examples of this, such as protein. Instead of drinking that whey protein shake that absorbs extremely rapidly, simply choosing an intact whole protein source like steak, chicken, or fish. Or if you feel you must get it from a powder, using a casein protein powder. And there's not too much we can do with fats. However, we can get these fats from the meat sources that we eat instead of adding oils. Simply just opting for foods that are more complex in structure and not processed or broken down can help us fight against having these very low energy moments throughout the day, and can help mitigate our risk of developing diabetes unknowingly, or simply just a milder form of it. With that being said, I hope this helped, and I hope you learned something new. And if you stuck around to the end, thank you.